Section 2, Java Basic and Fundamentals. My name is Darlington. Welcome to TechCodePractice once more. So today's going to be an exciting day. So let's take a look at what this section is going to be about. So you can read this list from bottom up. So if you look at the numbering, it's like 1, 2, 3, 4, going up all the way up. So first of all, we're going to talk about code structure. I talked about it last time a bit, but code structure is very important. You have to understand the code structure. Remember, last week I was explaining to you guys that, listen, if you want to learn a new language, you have to start from the ABCs, then you start going into learning words, and then going into sentences and all of that. And that's the journey we're going to take, because trust me, if you conceptually look at it like that, you're going to pick it up real close, because I really want to bring real world examples a lot to be able to tie it to your programming experience. Because in my experience, if you can visualize what you're doing or whatever you're programming to stuff or things you do in real life, then it's quite easy for you to grasp it. So that's what I'm going to do. So we're going to start with the ABCs, and these are the first ABCs and words we're going to be playing with. So the first is we have to understand the elements of Java code, the code structure. Then we'll be talking about variables. Variables are basically the building blocks of programming. Then we're going to talk about expressions, comparing variables with expressions. We're going to see what that means. What are variables? How can you write an expression? What is an expression in Java? How do you run commands repeatedly? Then we talk about loops. You know, if you have a line of code and you want to repeat that line maybe a couple of times, how do you do that? We're going to also look at decision making using variables and just data types in some cases. Then we move into methods, and methods are basically a bunch of reusable codes or commands that you can block, put in a block that perform a unique task, right? Then we're also going to look at, in this section, how to store more than one value in a single unit, and that's what you call an array. So some of these words might be new to you guys. Some of you that have already been playing around with code might have seen some of this in different languages, but this is the Java zone, so we're going to be playing around with Java and see how we express these concepts in Java. So we're going to start off with code structure, right? So we might already be familiar with this a little bit because we just did our sample codes. Most of you played around with it. I hope you also step back and look at it. But we're going to be breaking it down, right? So the first part here you see is called a package declaration. So what is a package? A package, just see a package in Java as a folder. So generally, when you open, I'm just going to pick up stuff. I'm going to bring this in here. When you do this in your computer and you create a new folder, you can say, okay, this folder is for cars, and then you create another folder. And you say, I'm creating another folder, and this will be people. This is how you order stuff, right? Maybe you just take all your car pictures and you put them in here, and then you probably, let me just zoom this out a bit, and you take your people pictures and you put it in there. This is how we know how to work with the computer. In Java, we also have something similar. We call that packages. But like I said, you have to think about it conceptually. So anytime you write this, you're conceptually creating a folder. But even IntelliJ is pretty cool with that, because just take a look. We could come right here in our source and we right click and you say new. And when you come all the way down here, you see this? You say, okay, I want a new package. So technically it's a new folder. And you can name it whatever you like. You can name it the folder. But Java guys always like to start their naming with com. It's just, I don't know why. I can't really think of why, but that's how you see most Java packages start naming this stuff. And I can name this package people. And when I save it, you see IntelliJ shows that up like some kind of a folder. And I'm going to come in here and create another package. I'm going to start with com again. Remember, the com is not important, but generally that's just a convention that is used. And the second one we had was cars. And I press save. So we have a package named people and a package named cars. Now take a look at what happens. I'm going to go into people and create a new class, and I'm going to call this class people, for example. So people, I could put the Java if I want, but IntelliJ takes care of that for me. And you see I have a people class here, and guess what? Look at this. It tells me that, wow, you're using people, and people is inside the package file, the package folder, and it names that, like, just does that up here, and which is quite similar to what we see up here. You see, so this is your package name. Now guess what happens? So I'm going to go back to my folder. So this was Constance assignment that she submitted, right? So take, for example, I want to make use of this this people class here, because it's actually an object I'm going to use, or that I created that I could use. But don't worry, we're going to get into that. But take, for example, just think about it. I want to use that class of people, right? When I come in here, I could say people, and I give it a variable name. We're going to talk about variables more, but just bear with me. I'm going to give it a variable name. And then, you see, when I hover my mouse over here, it's going to tell me, oh, would you like to import this class, which you guys have played around with. When I do that, now check what happens. It imported the people class, but guess where it imported it from? From the package com.people. So, yet again, that is what packages are. You use packages to organize your classes, put them in kind of conceptual folders or real folders, however you want to call it, and that way you organize your work. Then the next one is the import statement. So we just saw an example of that. Whenever you want to use any code that is outside your current class, so we have a superhero class, but we want to use a code that is somewhere else, you have to import that. So you can take an example. You can also take a look at this. It's the scanner class. So Constance used the scanner class to reading stuff, and you needed that. And some of you, based on the code I gave, used some other classes to read user inputs. But IntelliJ does also something interesting. Whenever you see an import that is a little bit grayed out like this, so you see it's not as white as this one's, right? So this one. So IntelliJ is kind of telling you that these grayed out imports, you didn't actually use them, so you could just delete them. So that's just what it is. And IntelliJ kind of helps you that way to see imports that you use and imports you don't use. Now, I'll give you another example, right? So you see here, I kind of called in the people class that I just created. If I delete it now, because this is the only place I'm using it in the whole code, check what happens. So I'm going to just delete it. And look at what happens. Up here, IntelliJ is telling me, it just grayed it out immediately. And it's saying, bro, you're importing people, but you didn't actually use it. So that's pretty cool. You can now delete that if IntelliJ shows you stuff like that. But it doesn't also matter if you leave it there. It doesn't cause a problem. But sometimes you want to clean out the code and make it look good. So you just clear out the stuff. So those are what imports are. So move to the next one. So how do you comment a code? This is how you do that in Java. You use this syntax. So you use /*, an asterisk, and you close it at the end. There are two ways to comment out stuff. So what is a comment actually? So take, for example, just as an example, you might be writing code and you're like, oh, I want to remember why I did this. So for example, you come here and maybe while I was explaining, you will be like, oh, I want to remember what this actually does. So you just come in here and you could write, you could do a slash and an asterisk. You press enter and IntelliJ closes it for you. And right in the middle, you can write your comment. You can say, this is used to get user input. So what happens is that when you run your code, when you get to this block, the Java compiler is not going to look at this as a code. It's just going to jump and go to the next line after this 11th line. It's just going to jump and go to the 15th line because you are actually telling the compiler that this is not code. This is just a text. It's a comment. I just want to use it to remind myself or remind other programmers what this is actually doing. So this is how you do that. Another way you can write comments in your code is, you see, when I take off that block, you see it tells me it's an error because now it's telling me this is not code. So there's another way you can also comment out a line is by using this /. So when you do that, it also sees that as a comment. So you're going to see these two ways of commenting stuff out a lot in Java. You can also comment out codes, right? So if I do something like this, if I just comment do this on this line, you would see that Java is no longer going to run this code. Now look at what's going to happen. It's not going to ask me for the first number anymore. It's just going to wait for me to put in stuff, because that's what this line is doing. So let's take a look at that. So I just ran it now, and you see it's just waiting for me because it skipped this line, and it's just waiting for me to put in something. It just got here. So now I'm going to put in 1, and I'm going to put enter. So now it's saying enter the second line, so which is this one. And that only happened because I commented out this line. So Java got there and just jumped over it or ignored it. So you can use that also to ignore some lines of codes and stuff, and stuff like that. So this is how you comment out code in Java. So I just showed you guys 2 ways, and when that's not the case and you have sentences, IntelliJ is going to warn you like, I don't know what this is. So great. We'll go to the next one. Then we also looked at class name. So when you create a class, it has to have this style. So the first one is the public, the access modifier. This is actually saying who can access this file. We're going to look into this in depth later. And then we have the keyword class. So this is a keyword in Java. Keyword means you cannot reuse this word anywhere. It's a reserved word for Java, right? You cannot come here and say int public. You see, maybe because of course this is an English word, but Java is telling you no, you cannot use it because this is something that Java owns. It's its own keyword and it doesn't want you to reuse it. So that's how you have to understand that. So you have to have public class, which is specifying that it's a class, and then the name of the class, right? So that structure. And remember, when you do that, you have to have an open braces, and then we have methods. So these are methods, and every method has a name. So a method, to write out a method as well, you start with the access modifier, and then we're going to get into what static is later, and then void main. This is basically how you write your main method. And remember, who can remind us what the main method is actually for? So I'm going to ask Sumbo. Sumbo, can you remember what the main method is and what it does in Java programming? You have to unmute yourself. You have to unmute yourself. Okay. So what about Obi? Obi, do you remember what the main method is and what it actually does? And when exactly. So remember, I used the analogy of a house, right? If I show you a house, I'm like, yo, look at my house. Go take a look. Go inside and look. If I say go inside and look, the first thing you're going to do is, okay, where's the door? I need a door to be able to go into the house to take a look. And that's what the main method is. So if I go back to our code, so we could say, oh, I just wrote a program, right? Oh, I wrote a program. Go ahead and run it. So how do you tell your computer to go ahead and run it? You press one of these buttons, right? So when you press this button is actually for IntelliJ anyway. But when you push it, what IntelliJ does is it invokes the Java the Java runner, and the Java runner is just going to go through all your code and is looking for the main method. If it doesn't find the main method, it cannot run. It will just tell you, bro, I can't find the door. So that's what the main method is, right? So we can see we have this main method all the way here. And now I could also, as an example, I can also comment out the whole of the main method and check out what happens. So now that I commented out, you see the whole play thing is gone. Because in the whole computer, in the whole file, it cannot find the main method anymore. So it can't even run it. And this is IntelliJ even helping you, telling you, bro, I cannot put a play anywhere because I can't find the main method. Even if I go into remember we had this people class, this people stuff here. Yeah, it looked in here and it couldn't find the main method either. So the main method is the door to your program. So when we reverse that, then we see our play icon appears again. And now we can run the code. So this is how every program you write needs to have a main method, right? It needs to have a main method because that's how the Java runtime is going to know where to start running the program from. And when I mean a program also is not only this file. A program is everything that is inside this folder. So Java actually goes and scans both superhero, counting string, people. It looks everywhere to look for the main method. So probably you guys also hear me use the word method. You're hearing that a lot. Method. So method, remember, I was giving you guys last week an example, the difference between properties and behavior, right? You guys remember? So I said a human being has properties. If I have a person has a property of a skin color, black, what other things? T-shirts, white, and stuff like that. But we also have behavior. So behavior is like speak, walk, punch, dance. So in Java, how you declare behavior, we call that method or function. But in Java, we mostly say method, but you might hear people call it function. It's the same thing. So function or a method describes a behavior, that's something that needs to happen. So you can see exactly in this program we wrote, we have in this our main method. Keep that word in mind. In this our main method, it has to do something. So you see, what did it do? That something it did was it accepted users' inputs and then it printed out a result. So it did something. It's an action. You get it? So we use that word method a lot. So when you're talking with your fellow programmers and they say, oh, write a method that prints out run. That means you're writing a behavior that prints out run. And we're also going to see how we're going to write properties later. So I'm just making you guys remember those words. So you see here, the word is also used here, main method. You see that? Method. So main is the door to a program in Java, but it's also a method. It does something. It's a behavior class. And remember, this is how you write it. The syntax is very important. You write a public static main void main, and then you put a string args. This stuff we're gonna look into it later to make you understand what it is. And then you open braces and you close braces, and then you write inside it what needs to happen. But you also see we have another behavior in this example that is called print message, right? By the way, I want to specify that I got this screenshot from W3 Resources, from the W3 Resources website. This is not my picture. I did not draw it myself, so disclaimer there. But anyways, this method, as you can see here, so this method is also doing something. It prints a message. It's a behavior. It does something. And what it basically does is it just prints out the message you find in the system.out.print. So this block is called a method. It's a behavior. It does something. And the syntax of that, we're going to look into that more and more as we keep going. So this is something probably you guys need to see often, analyze, and you get used to it, right? So we're gonna try it out. You actually make mistakes when you start typing your own code, but as often as we do it, you're gonna get used to it. Now we're gonna go to the next screen, and this is important. This is exciting. This is the part where we're gonna be talking about variables. What are variables? So I would like some of you to raise up your hands if you have heard the word variable before, and where have you heard it? So I'm going to start with Ishmael. Have you heard the word variable, and where did you hear it? Okay. All right. So Constance, what about you? The first time you heard variable, where did you hear it? Or in what context? All right, good. Let's move to Sumbo. Exactly. Obina? Obi, you mute? Chinasa? Good. So it's very important to link those places that you heard it. So for those that already got it through programming, fine. I think you have a pretty good idea. But yes, most the word variable actually, for anyone that hasn't touched programming, it will be math, right? And the concept is simply the same. But even in programming, it comes to life even more. So what is a variable? A variable is just something you use to store information. And in Java, it takes up space in the memory, and it changes depending on what you put into it. And I have a picture here of an example of what a variable is. I think if you understand this picture, the word variable is just going to stick, right? So this is a very simple puzzle. So if we look at the first one, we see a chicken lap plus a chicken lap is equal to 4. So the trick there is you want to like figure out what is actually a chicken lap, or what value is a chicken lap, right? So I think it's safe to say that the value is 2, right? Which is what they want you to put here. So 2. So that means chicken lap is equal to 2. So anywhere you see chicken lap, you're going to attribute that as a 2, right? And then 2 plus 2 will now be equal to 4. So you're not even looking at it as a chicken lap anymore. You're looking at it now like the value in it, which is 2. So you'll be like, oh, 2 plus 2 is 4. Then you go to the next sum and you'll be like, oh, I know now that chicken lap is 2. So that means 2 plus 2, which is 4, minus a value would give me 2. So what would this value be? That would probably be 2 as well. So you're going to put 2 here. So we have another variable, which is cake, and it holds 2. So from this point on, whenever you see that cake, you're going to put the value 2 in your head. So this is exactly what variables do. They are just a way to store value into something you want to use later. And that is exactly how Java uses it. Now, do you guys understand this concept? Raise your hands if you do. Okay. So now put this in mind, and then we go to the next. Sorry, let me see. So have this in mind, and we'll just go over to the code, and let's just see what that looks like. So you guys have already been playing with variables, but I just didn't tell you guys, or maybe you guys didn't know, or some of you know, those that are already playing with code. So this is an example of a variable already, or this. Sorry, this is the variable. What you see here. So I can say something like, let's say, so we're going to. I'm still going to explain what this int is, right? But this, what you see here, num1, that is the variable. So I'm going to also write another one. I'm going to do something like this: string person's name is equal to Darlington. So what is the variable here? It is this guy. So anywhere in my code where I use this person's name, Java is going to know, oh, it is Darlington. So it's just going to look at what's inside it and just print it out. So if I do something like this, I say system.out.println, and I say person's name, which is the name of the variable. So when Java gets here, what is it going to do? Just like the chicken lap, it's not going to print person's name. It's not going to say person's name. No, it's going to look at what's inside it, which is what I have done here, and it's just going to print Darlington. So let's take a look at that. Let's run it real quick. I'm going to run that, and you see it printed Darlington because it looked inside the variable name, which is person's name, which I gave to it, and then printed out what's in it, just like our chicken lap. So now, what is this string thing I put in front? What is this int? What are all this? Now, great. That's going to take us to the next part. and that is what we call data type. So what is a data type? Now, there's something that makes Java very unique compared to other programming languages. It's because Java is a strongly typed language. What does that mean? Strongly typed language. Now, remember we had this picture of a chicken lap, right? Now, what Java does is when you have a variable, so this is an example, right? When you have a variable, Java will force you to tell it what can you put in that variable. You cannot just have a variable my num and Java is gonna guess. Maybe it's gonna be a number, maybe it's gonna be a string, a person's name, maybe it's gonna be a decimal. No, you have to tell Java this chicken lap you want me to use as a variable. What kind of value, what kind of data type? That's what that's what we call it. What kind of data type? Data type actually means the value. What kind of value must I save in this thing? Because if you don't tell me, I'm not going to save anything inside it. And that is why we call Java a strongly typed language. Java will not allow you to just put anything into your variable. No, you have to tell it what do you want to be inside it. And that is what we do using data types. So the data type is actually the type of value a variable has, and sometimes it could be a mathematical stuff or it could be a logical stuff, and we'll see what that is. So for example, in this block we have here, we have a variable called my number, right? But we want this variable to hold only whole numbers. Remember, whole numbers are numbers that don't have decimals, it doesn't have a dot. And how do you tell Java that? You use the data type called int, int. We're going to look more into this in our next slide. Then we also have another variable called my float number, and Java is going to be like, okay, what kind of stuff can I put inside here? You say float. Float is actually saying I want you to save a number type, but a number type that has decimals, because whatever I want to save, you're going to have decimals. And in what fields do you use decimals? You probably use decimals in your measurements, maybe weight size. Somebody weighs 90.5. You see there's a decimal there. For money, you have writing a software where you want to ask people to enter amount, or you want to display an amount. It's normally has decimals, so maybe it's 10 euros 50 cents. So you see there's a dot there, 50 cents. So you use floating points or a float data type. Then we also have the char data type. As you can see here, the char data type can only take one word or one letter. It can only take one. So if you have any data that you know it's only one, you use a char. Can anyone think of a data that you might want to save in a char? I can. For example, you have in some forms they will ask you, are you male or female? And they'll put M or F. So if you write a software where you want people to put in their gender, well, you can use a char. And that way you tell the person you can only put an M or an F. So when the person puts it in, you store that in a char variable. And this is how you declare it. It has only the single quotation sign, right? Then you have Boolean. Boolean is an interesting data type. It's actually a logical operator data type, which when you hear the word logical operators are mostly operators or things where you have true or false. Is he a boy? Yes. Is he a girl? No. You understand? Or you want to define a state. So in this case now, I could be like, I could name this variable. I could name it light. Or okay, I can name this variable is on, maybe for a light. Is the light on? And I could say true or false. So the Boolean can only take two values. It can either be a true or false. You cannot put text in it. You cannot put numbers. No. When you define a variable as Boolean, it takes only true or false as a value. Right? And we're going to see some of this in practice as we go. Then we have the most popular string. So any text in English or in any language where is not a number and is not a boolean and is a combination of words or letters, that we call a string. And this is how you do it. So we have a variable here called my text, and the data type is string. So you see, typical word comes in here, hello. So to expand even a little bit more, these are the data types that Java supports. I don't want to go too deep into them, but I want to show them to you so that your eyes will just be like, oh, I've seen this before. So remember, we already played around with some. The integer, we've played around with it. The integer only takes whole numbers. The long takes whole numbers, but can take way more numbers than an int. So you see, an int takes just 4 bytes in memory, and a long takes 8 bytes. But look at the amount of number an int can take. An int actually means integer. Well, in Java, as a keyword, it's called int. So whenever you want to store a value that is between minus 2, I think this is 2 billion or something, to 2 million. So you see it goes all the way from negative to positive, but it's quite a lot of numbers. If whatever you want to store is within this range, then it's better use bytes. If it's even smaller, you could use short. If it's even smaller, which you see, if whatever you want to store is between minus 228 to 127, then you can use bytes. So, but I don't want to go into this so much, so I don't cloud you guys. But what is the takeaway here? Takeaway is, when you have a variable, you must tell Java what you want to put inside that variable, and you do that using data type. Now, I want to draw your attention. This list you see here are called primitive data types. Primitive data types are mostly types that are defined by Java themselves. They are not an object. They are not a class. And I'm gonna explain what that means as we go on. But they are already like keywords that are defined. They come with the Java package, and they do specific tasks like this ones we see here, and they are stored directly in your memory, in the memory of the computer. But we also have the other one which we looked at, which was string. So you see we have string here, which I explained that you use that to get words or sentences and stuff like that. So you see the string, the keyword, the data type actually starts with a capital letter, while the primitive types, all of them start with small letters. See? Byte, small letter, short, int. And this is unique to Java, right? So this is how Java does it. Java is like, yo, if you want to give me a data type that has any of this stuff, it has to be small letter. So it knows, okay, it's a primitive type. But if you want to put a string, which is a word, a sentence, anything that is more than one letter is a string. So you do that using, when you write that, the data type is a string and it starts with a capital letter. So this is not a primitive data type, which means it's actually a class. Java actually has a class called string, and it uses that to help programmers to define string values. And this you call non-primitive. So I'm throwing a little bit of more words to you guys. You might be hearing it. You might be like, yo, we've heard the word primitive now. We've heard the word non-primitive. Primitives are like the ints, the bytes. They're all small letters. And in Java, there's another one called non-primitive, a string, and we even have some more of them. So most of the classes or data types that start with a capital letter, like I have an example here. Anyone that starts with a capital letter is actually a non-primitive type. Okay, we're gonna see more what that means, how that plays out in terms of memory. We're gonna see that later, but I just want you guys to understand those distinctions. I want you to also hear those words: primitive, non-primitive. You also hear the word object reference when we're talking about non-primitive. So we're gonna play around with that and see what it looks like as we go on. So one more thing I want to show you guys before we dive into coding is this part, how you declare variables. So let me get rid of this. Sorry. So how do we declare variables? Very important. We have played around with it like I mentioned before, but it's very important. Let me get rid of this, all this squidgy stuff here. So it's very important we know how to declare it. Remember, Java is case sensitive. The word case sensitive means a small letter. If two things have the same name, but one has a small letter and the other one has a capital letter, it's not the same in Java. It is case sensitive. So your variable names, you have to follow certain rules, which we'll also continue to discuss later. But first off, this is how you write a variable. So let's see. Sorry, this is supposed to be here. Oh, my mistake. So this is how you write a variable. The first thing you write is the data type. And remember, we have looked at different data types. We have the int, which you see here. If it's a number, if it's a decimal, it needs to be a float. If it's a if it's one character, you use char. Boolean is something that holds just true or false, and string is for text. And then the next thing you want to write is the name of the variable. So typically, when you want to write the name of a variable, it should always start with a small letter. Is it a must? Absolutely not. It's not a must that you must start your variable name with a small letter, but it's convention. You know what convention means? Convention means that is how all Java programmers in the world have decided to do it. They're like, yo, that's how we were going to do it. So, at the point when you start programming in a language, you kind of join a cult. Sorry. So you guys actually, I'm preparing you guys to join the cult of Java, and the Java cult has a way to do things. I'm just playing. But that is what conventions are. Convention is just more like, okay, Java programmers agree generally that this is how they're going to name their programming, their variable names and stuff. So if you adhere to that convention, it makes other Java programmers happy. When they look at your code, they're like, okay, this is what I'm used to. This is how you should do it. So don't be surprised if you write your Java code and someone is like, can you make that small letter? Why did you make it capital? He's just saying that because that's what we're used to as Java programmers. So how do you declare that? We see the first line, data type, name of variable. But you also see that at the end, you did not assign this variable anything. This is perfectly acceptable in Java. But that means that this variable holds nothing. It's just empty. You just declared it, but it has nothing. But you can also declare the value directly. So you can say 3. I can change this to 3. So you have your data type, variable name, and immediately you put something into it. Just like our chicken example. You have your chicken and you put a number into it. So I'm going to ask a question now real quick before we play around with the code, right? So what data type should this be? I'm going to ask Sumbo. What data type do you think I should put here that I just highlighted? This one here. Okay, and why do you think it's supposed to be char? Sorry? No, I mean here. I mean the data type, right? So the variable name could be anything. But you believe I should put char here, right?
Oh, okay, no, int. Okay.
Oh, okay. Why should it be int?
So there's a number there. Number 3, which is a whole number.
Great. So that's correct. So definitely this should be an int data type because we can see from the results it's accepting. Just give me a minute. You can see from the results it's accepting a whole number. All right, let me try something else. Let's make this M. All right, Chino. So what are we gonna make this? Why? All right, thank you. All right, let's try something else. Obi, what data type do you think we can use here? Obi, can you hear me? I can't hear you, Obi, if you're talking. All right, okay, we'll skip that, and I think Obi's network is jumpy. So we're gonna go to Constance. Constance, what are we gonna make this data? Oh, wait. Obi is back. Obi, are you back? Yes, I can hear you. All right, Obi, shoot. Boolean. Why? Okay, so the answer is wrong, and I'm going to tell you why. Actually, this is actually going to even give you an error. Why? Because of this quotation you see here. So you can only use this quotation if it's a single character, one. But if I also had done it this way, it would also be wrong if you put a char there. Why? Because you put a quotation, and quotations are strings. See that? So if you want it to be Boolean, you have to get rid of the quotations completely. Now it's a string. Now it's a Boolean. So don't get it twisted. If you do something like this, or you do something like this is a string. Because strings are words, could be even numbers, that when the program looks at this, it just sees that it's a string. All right, let's move to the next one. Constance, what data type do you think this should be? All right, the answer is also wrong. Why? Because I also have a quote here, and quotes are strings. So whenever any variable has a quote, it's not it's a string actually. So if you want to make it a float, what you have to do, take off the quotation, and you always have to end it with an F. So Constance, shoot, question. You thought it was what? So I do something. Mean something like this? It is a string. So just basically, just think about it like this. Anytime you see quotation around anything, is a string. It doesn't matter if it's a number. It doesn't matter if it's a true. It doesn't matter if it's 8. It's as long as it has a quotation, it's a string. Yeah, just remember it like that. Anything that has a quotation is a string. All right. Let's go to the next one. Does anyone have a question as well? No. So if I give us this one, what data type should this be? Why? What if I do it like this? Did you guys see what just happened? We have the same stuff, but one had a single quote. It's also just one, so it's a char. If I did something like this would give me an error in Java, because Java is like, oh, whenever you want to use single quotes, it must be only one. So I don't know what this is. So it's going to give me an error. And if I wanted it to be like this, then I have to change it to a string. Oh, then it'll be like, oh, okay, oh, I get it now. So it's a string. Oh, I get it. But if I change it to, okay, I'm coming to you in a bit. If I change it to this, it'll be like, I know what it is. It's a char. That's it. Let's go. But it's not going to see it as a number. You can also not do calculations with it. We're going to see what that looks like in a bit. Obi, shoot. Yeah. Okay. So the char, like I told you, you have to let's use some ideas to group what is primitive and non-primitive. So I want to make it easy for you, because this could be a question you could get in a interview if you're going as a junior programmer. They could give you a bunch of data types and tell you, show me the ones that are primitive. First, you want to do is just check the word. What does it start with? Does it start with a capital, or does it start with a small letter? If it starts with a small letter, it's a primitive data type. So this char is a primitive data type. But then they also give you this one that also uses double quotes. This is not a primitive data type. This is a non-primitive data type. Why? The simple way to figure that out is the first letter. It starts with a capital S. Do you understand? So they both take values with quotes. Chars take single quotes, and strings take double quotes, but you write them differently. And one of them is a primitive, which is char, and the string is a non-primitive. We're going to see this more, what this means in terms of memory, because these two stuff, primitive and non-primitive, they behave in a kind of different way in your computer memory. You understand? Not that you need to know anything about it when you're programming, but not that you need to be worried about how your computer is doing stuff, because Java takes care of that, but it's good to understand what's happening under the hood, because that's also going to help you in deciding what to choose in some instances, especially when you want to save memory and stuff like that, or most especially when you want to manipulate the value inside of it. But that's just going to come later. But to answer your question, small letters, when the data type starts with a small letter, it's a primitive. When it starts with a capital, it's a non-primitive. All right. So let's dive into some code. Let me see. Do I have? All right. So let's get you guys busy for a bit. So I'd like you guys to play around with variables. So let's see. I'm just gonna type the assignment directly here. So I'm gonna do something like this. Okay. No, let's do this together. Let's make it more of a group task, right? So I'm gonna get rid of all of this code. So we're still gonna use this as superhero class, because we can use it to do stuff. So I'm gonna write codes, and you guys are gonna tell me what to do here. So I want to write a form. I have a form that I'm going to use to register usernames, right? So who do we want to register this time? So we want to register. So this is let's say this is a registration for, what is it everybody has gone to? I would say to the hospital. You're going to the hospital, and you have to register yourself in. This is the first time you're coming to the hospital. and the hospital is like, yo, we need your data so that we can be able to store it in our database and stuff, right? So the first thing you're gonna give is your name, right? So Obina, what name would you like us to give? What name do you register yourself with in the hospital? You don't have to say your surname if you don't want it. It's just for test. So what name should we call you now that you're registering to the hospital? The audio is gone again. Okay. Right. I'm sure you can hear it. So let's go to Constance. Constance, what name should we give you here? Oh, Obi's back. Sorry, Obi's back. Obi, shoot. All right. Let's use Obi. So Obi, right? Okay. So this is it. What's the problem here? Who can help me out? I want everyone to give me the first problem because I'm defining a variable. The name of the variable is the name of the variable is name, but I'm having a problem. It's red. I don't know. What am I doing wrong? So each person will just give me one thing they think I'm doing wrong, so I can share it with everybody. So we're gonna start with Constance. Constance, give me one problem with this variable. Okay. All right. Let's try that. So I'm gonna say string. All right. I still have a problem. Sumbo, what is the problem here?
String Obi has to have double.
Oh, double quotations. Oh my God, shit. That is all messy. Oh, thank you. Okay, I still have a problem here. So please help me out. I don't know what's going on. All right. Let's see what that's about. Perfect. So let's give it a try. So let's do system.out.print ln. I call my name variable. Let's see if that works. Run. And there it is. OB is printed out. So this is indeed how you write. You declare. Remember the word? This is how you declare a variable. Very good. But what if I do something like this? I want to change my variable name. So I said, this is the name I give anyone that is trying to register. And I come here and I copy the variable name and I put it here. So tell me, will this work? I'm gonna start with Chinoso. Chinoso, is this gonna work? What do you think? Okay. Okay. Sumo, what do you think?
I think it's gonna work.
Why?
Because that will keep in string, so it doesn't matter how long it's stored.
Okay. Do you agree? Okay. Constance, you agree? Okay. Obi? Okay. Alright, let's give it a try. and see what if you guys are correct. So let me just change the name to OB, change to OB Sun, just to differentiate it with what we have here, just to see. So let's go, and it worked. So I think the message is clear. It doesn't really matter how long your variable name is, it's still going to work. It's still that chicken lap. That's just what it is. Although this might be a long variable name, but I'm even going to show you guys a better way to write it. But it doesn't matter. That's the point I want to make here. All right, let me try another one. What about this? This is the name of the person. So this is my variable name, and I copy this variable name and I put it here. All right, guys. Chino, so you want to try again? It's gonna work. Did you get the answer of the last question? Yeah, but did you get the answer of the last one we did? No, yes, exactly. Okay. Okay, yes, exactly. No matter how long. But I'm asking the question for this one is, will this work? I just changed the string name, the variable name to this is the name of the person. The way you see it on the screen, will this work? Why? Okay. Obina, you agree? Why? Oh, okay. Constance, you agree? You find you agree as well, right? Okay. Sumbo, what do you think?
Also, I agree because the very beginning is like just an error, so it's not going to.
Okay. Let's give it a shot. And there you go. It's giving us errors. Even Java is confused. It doesn't even know what you want to do. And what you guys said is correct. The problem is the spacing. Now, it's true that IntelliJ is giving you all the squiggly lines, but that's because you're using IntelliJ. But it's good to know why this is happening. And you guys nailed it, the spacing. The spacing is the problem. So if you're naming a variable, you have to get rid of all the spacing. It has to be one full word as a whole. And we can do that here. And then that's it. Great. So we have Obi's name, Obison as the person registering. Then what about this one? So we went to age and we said ages 55, 56. So Sumbo, what data type should this be? Int. Okay. Int. Good. Then we have the next one is probably what you also get in this stuff, address. So Constance, what should this be? What should be a string like this? Oh, the capital letter. Great. And then what else do they ask for? Phone number. So I'll say phone number. Yes. Obi, what data type, please? Yeah, what data type for this phone number? Alright, oh my god, something's wrong. What is wrong? But I did not put the apostrophe out. This is how I want it. This is how I want to store my telephone number. So what's the problem?
What did you say? I can't hear you.
So does the way I want to store it, does it fit with the data type? So all right, there you go. Right, so that's very important. So you see the squiggly is gone. How you want to store it. So you as the developer, as the programmer, you are going to decide how you want to store it. It's your decision. So it doesn't matter. Sumba could decide to store it as a number. I could decide to store it as a string. It's your decision. But anytime, like the rule of thumb that I normally use is, if you're not going to do any calculation with this telephone number, if you're not going to do any kind of calculations with it, you can store it as a string. Anything you know you're not going to do any calculation with, store it as a string. But it would not make sense for you to store age. So let's leave this way. It would not make sense for you to store age as a string. You could if you want. Remember, it's a decision of the programmer, right? But it wouldn't make sense to store age as a string. Why? Because maybe sometime in the future you might want to do a calculation with it. You might want to say, what would be the age of Obison in 10 years? So if you want to do a calculation with it, you cannot do calculations with strings. You can only do calculations with data types that only accept numbers. So when you're programming, you have to have those kind of thought in your mind, like, okay, there's a high likelihood I might do some calculations with this value. So let's leave it as an integer. Let's leave it as a floating point. Let's leave it as a double. So as you can remember, let me go back to the slide. So if you remember, let's see. So we have all this data types, primitive data types that store numbers. You see, this one stores whole numbers. This one stores whole numbers. This one stores floating point numbers. Up until this part, the only two primitives that don't store number is Boolean and char. The rest all stores numbers. So if you're writing a program where you think you're going to probably do some kind of calculations with the value, please do not use string. It's way better for you. But of course, you can do whatever you want, because you as a programmer, you are the one responsible for that. So I'll take this back. So let's see. So let's say sex exactly. So we'll just call that gender. Make that. All right. Ifeanyi, can you help us with the data type? Okay. Let's give that a try and see if that's correct. Oh my God. It's broken. Ifeanyi, you broke the code. Oh. You see, I gave you a trick one there, but he has corrected it. It is a string. It is a string. So remember, very important. If you have a double quote on anything, even if that thing is 1, it should be a string. So let's see. String, and as you can see, the error is gone. And if we print that out, it's going to still give us the output. Sorry. So it gives us M. But Of course, it doesn't make sense if you know you're only going to be accepting one letter. It doesn't make sense to store that as a string because string takes more space in your memory, in the memory of your computer. So since you know it's just one character, then it's best to change that to a char. Do you guys have any questions with what just happened? Is it confusing? If it's confusing, raise up your hands, please. Okay, great. So let's go on with our slide and see what's next. So we already looked at the non-primitive types. So strings are not primitive. In fact, any data type that starts with a capital letter is a non-primitive type. And we're going to see more and more of this. I just want you guys to be familiar with it, like just looking at it to just so like, oh, I've seen this before, but you don't have to remember everything right now. As we start to play around with them, you would see them. But definitely I want you to familiarize yourself with the words arrays, strings, bytes, short, integer, long, float, double, all of this, as well as the non-primitive types. The primitive types we discussed, which is this one, is the same: bytes, short, int, long. You don't have to remember all this information of how much data they can store. Trust me, I don't even remember them. I know that anytime I want to use it, mostly I use int. Most of the time, anytime I'm dealing with numbers, especially whole numbers, I use int. Sometimes when I'm dealing with numbers that I'm sure that it's not going to be very large, then I start going down. Or when someone asks me, oh, how much does an integer hold? How many data can it hold? Trust me, I Google it. I just go and Google it. I don't remember all of this. I don't really care. All I know is it just holds a lot of data. And whatever I'm programming, if I know that the program is not going to take a lot of, like, going into millions. You see, this is like, I don't know even how you call this number, but it's in the millions, so it's not billions, right? Yeah, it's in the billions. As long as my numbers is not going to go into the billions, I'm okay with it. But mind you, if you're writing a software where whoever gave you the contract to design that software is very keen on memory management. That means your employer wants you to not overuse the memory in your computer. You want the program to be able to run as light as possible, that when people are running it on their system, it doesn't take too much memory. Then you have to pay attention to this. Then when I want to write a program that takes a number, I would come back and be like, okay, this variable that is going to take this number, how large is the number? Maybe the number is never going to be above 25. I'll give you a typical example. If I'm going to store a number age, we know there's nobody that gets to 150 years old, right? Why would I use int for that? Because int will be taking too much memory in my computer to store it. So ideally, because I'm sure in this case, my employer wants me to manage space, I would typically use a byte for that. Because you see, a byte does not go above 127. So I don't think anybody lives up to 127 years. So people only live from between 0 years old to 110 if they're even lucky. So bytes will be the perfect data type to use, because that way you're managing the space in the memory when the program is run. But if someone is like, yo, I have one of my uncle, he lived up to 130, fine. You just move one level down, short. And you see short goes up to 32,000. It takes up to 32,767. So there is nobody that's going to get up to 32,000 years old. So you could use this. But it's even though it's ridiculous, but you can use it because somebody argued that, oh, his father was 130 years old. And we know that if you put 130 years old in bytes, it will give you an error because bytes does not hold more than 127. You get it? So those are the instances where you might consider, switching it up and paying attention. But generally, most programmers, when it comes to whole numbers, they just go with ints. Everybody uses ints. Just keep going. If whatever your story is going to be way bigger, people go for long. And the same for floats. If it's a decimal, everybody uses float. If your floating point is going to be way more, like you see this one uses 7 decimal digits after the point, it takes 7, but in some cases it goes even longer than 7. If it's going to go up to 15, you just use double instead. So these are decisions the programmer has to make for himself, and sometimes based on the requirements you're getting, you can switch it around. All right, let's move on to another exciting part before we do a quick lab session. It might also seem like I'm spending a lot of time on this, right? Now, like I explained to you guys, this is the ABC of Java. This is like me teaching you guys ABC to Z. If you understand this basics, this variable, how it works, then you can start building on it, right? Then you can start building your language on it, just like you have the ABC. You start building words, you start building all of this stuff. So it's very important. I really want you guys to understand this very well. So we've played around with variables on the code, and I see you guys really grab it, really good. So the next thing I want to discuss is naming conventions. Remember, what are naming conventions? Naming conventions are not really rules. You understand? I will instead of me saying rules here, I'll just make it more of conventions. Now, naming conventions are just more like some are actually rules, and I'll separate the rules from the conventions. So I'll let you know which ones are rules and which ones are conventions. So first, rule. This one is a rule. Variable names are case sensitive, which means if you have a variable name called my name, and we have this one that is also called my name, they are not the same. What do I mean? Let's look at the code. So let's go to code. I'm going to play with this. So now I'm going to have a variable called string my name is equal to Darlington. Right? And I now come here. I want to print out my name, right? And I'll do something like this, my name. This is not the same. Even this is going to give us an error. Take a look. And what is it saying? It's always good to read your error. It says cannot find symbol. And what symbol can it not find? It cannot find my name. And you'll be like, huh? Look at my name here now. Why? I have a variable called my name. Why is it not working? The reason it's not working is because in Java, variable names are case sensitive. This M is capital and this is small. So in the memory of the computer, it's going to say, I don't know what this is. So these two stuff are not the same. So to make it work, you have to use the exact variable name, which is a small letter. When you run it now, it works fine. Or if you did something like this, you said my variable name with a capital, and I say Sumbo. These are completely two different variables. They are not the same. One is Darlington and one is Sumbo. So you also print them separately or differently. So we run that again, and you see they print out Darlington and Sumbo. They are not the same. So that's the first rule. Variable names are case sensitive. My name with a small letter and my name with a capital letter are not the same. Alright? Clear. Second one is you cannot declare a variable name 2 times. What do we mean? And also, when I mean 2 times, you cannot declare it 2 times within the same scope. What do we mean? So take, for example, we have string my name is equal to Darlington, right? This is what you call a declaration. You have declared to the program that, okay, I have a data type of string called my name is a variable, and I'm putting Darlington inside of it. So this is what you call a variable declaration. You cannot also come down here again and do the same thing and now say Sumbo, because it's the same and you are declaring it. Because when you're declaring a variable, that is when you give, at that point you have to tell the data type. So anytime you have to give the data type directly as the stuff you're putting inside it, this is called a declaration. You're telling that, oh, I have a new variable name called my name and it's called Darlington. I mean, the value inside it is Darlington. So you cannot come within the same scope. This is the scope, huh? Scope means within this bracket, within this curly braces of this method. This is your scope. You understand? Within this same scope, you cannot come here again and say, my name is equal to some symbol and giving it a data type. This will give you an error, and you can already see it's squiggly. That's the second rule. But if I take away this data type from the second one, then it's not a problem. Do you know the difference between these two? Can someone tell me? Let me see. Let's try some of those that I've been programming a bit. Constance, can you tell me the difference between line 8 and 9? Why is it now okay? Exactly. That's exactly the answer to that. So the first line is a declaration. Declaration means this is the first time I'm telling the computer about this variable called my name, and because it's the first time I'm telling you what type should be inside it. The second one is not a declaration. The second one is an assignment. Assignment is like you're assigning something to something. You understand? So this is not a declaration because this is not the first time you're talking about this or you're presenting this variable, but this time you're changing what's inside of it. So this is acceptable, but you cannot declare a variable two times within the same scope. Now let me also explain that word scope so it will be clearer to you guys. I can actually take this from here and put it up here. And this is fine. Because this is a different scope. Look, this scope starts here and ends here. This is the scope of the class. So it's okay because it's not in the same scope as this one. Even though this whole method is inside this bigger scope of class, but this method has its own scope in itself. But within the scope of this class, see, the scope of the class starts with this curly braces and ends here. Within the scope, I cannot directly come here again and declare the same variable. See, now it's in the same scope. So this is not allowed. So you cannot declare a variable within the same scope twice. That's the information I'm trying to give. You can also have a different method. Let's try another one just to you guys separate examples. You can also have another method called public void run. So run. So this, like I told you guys, method is actually a behavior. You're doing something. So I'm gonna say in this my method, what I wanted to do is what I wanted to do is just print the phrase I am running. Right? I can, however, come in here and also say create another variable with the same name and say symbol. So this is also fine. Why is it okay? There's no error here. Why is this okay? It's okay. You see, if I run it, we don't have any error. It prints out Darlington. It's okay because it's not in the same scope. This is in a different scope. This is in a different scope. But if it's in the same scope, it will not be accepted. Raise up your hands if you have any questions on this so far. Okay. No hands. Great. Now the third one. Someone has a question. Shoot also. Shoot. Yes. Yes, that's correct. So Constance is asking, Chinos is asking, is it possible to have a variable that you prevent people from updating? Yes, you can do that in Java. We're going to talk about that later as we go on, but since you brought it up, I'm going to show you an example of that. So we had this example where we said my name is Darlington, and then here we just changed it to Sumba, right? And then we now printed my name down here. So the question could be what would this program print out, right? Is it going to print out Darlington, or is it going to print out Sumba? Well, it's going to print out Sumba because first it was Darlington, and then on line 9 the programmer changed it to Sumba. So when we run this now, it's going to print Sumba because it was changed on line 9. But Chinoso is asking, what if I don't want anybody to change this Darlington? I want it to just still be Darlington. Then you have to say that when you're declaring your variable my name, and you do that by using the keyword const, I think. Yeah. Sorry, it's not here, but here. The constant. Just a minute. Let me see what's the error here. Unexpected token. Alright, let me just Google that because I think I forgot the keyword, but that's possible. Let me see, Java constant. Let me see, declare constants. Let's see how you do that real quick. See, even myself sometimes I have to Google out some stuff because I pretty much forgot it. How to declare constants in Java? Let's see. Yeah, sorry, that's it. Use final, exactly. Use final for that. So I actually programmed in C# as well, and in C# we use the word const. So that's my mistake. There's a difference between C# and Java, and sometimes I mix them up. So of course use final. And when you use final, what this is actually saying now is that you cannot change this variable, and you see it's already giving us an error. And if we run that, it's going to give us an error. It says cannot assign a value to final variable my name. You understand? So it's a good point you brought up. We're going to look at this stuff later, but you see the idea is the same, right? Because so you said you did that in Java. But you see, the idea is the same, but Java uses a different syntax called constant, const, I think, right? But you see, the same idea exists in Java, but the keyword is just different. It's called final. So this is basically how you do that if you don't want anyone to update the name. So now that I took that off, if I run it again now, you see it prints out Darlington, and now nobody can change it. So that's also very possible. All right, so we'll move to the next one. And let's see. So so when you are declaring your variable name, this is also a rule. When you're declaring a variable name, okay, sorry, these are not conventions. I'm going to take this off. These are actually rules. All this stuff I mentioned here are rules, actually. So if you want to name your variable, you can. It has to start with a letter, a $, or an underscore. So like this, you can name your variable this. It's acceptable. It's okay. You can start it with a $. You can also start it with an underscore. It's also okay. Java doesn't have a problem with that. And also, what can you also start with? Yeah, I think we've tried all of that. Or a normal letter, just like we have the N there. However, you cannot name it starting with a number. You see that? You cannot say one my name. No. That's Java is not having that. But you can put a number in between after you've respected the other rules. So for example, you can say my one name. You can put 1 here. You can even put 1 immediately after the first letter. 1. And that's also acceptable. So remember, you cannot start it with a number. No, that's not acceptable. But you can use a number in between somewhere, but never starting it with a number. That's not acceptable. Java is going to give you an error. So that's this one we just mentioned here. You cannot start with a number. Then the last one is you cannot name your variable using a keyword that Java already owns. For example, what keywords do we already know? Do you guys even know what's keyword? Can someone raise up his hand if they don't know what I mean by keywords? Java keywords. If you don't understand what I mean by keywords, or if I say you cannot use keywords in Java to name your variable, if you don't understand what that means, please raise your hand. Oh, everyone understands it? Awesome. Great. So, example of keywords, for example, are the ones you see here. You see public class is a keyword, so you cannot name your variable public. Sorry. See, you can't because it's a keyword in Java. Those are words that Java owns. It's for them. They're like, yo, no, you're not gonna use it. This is for us. You cannot name your variable class. No, it's a keyword. Look, that's how you that's how you create your class. You say public class. You don't want to use that word class anywhere. Don't do that. It's for us. So you cannot do that. But you can say public class with a capital letter. See? Remember I told you variables are case sensitive. So Java is going to be like, okay, this is not us. You can do this if you want. It's for you. The one we own is the one with the small letter. So this is okay. You can do this. But this is not okay. You cannot use their keywords. You cannot use, what other keywords do I know? Let's see, I've made a list of it. We have all of these keywords here, as you see on the screen. These are all keywords that are in Java. You're going to learn most of them as you go on, you understand? You cannot say, you also cannot use the word int. Int is a keyword. You cannot use the word byte. Byte. Remember, bytes are actually data types, and they are also keywords. So all this stuff I showed you guys here, sorry, what was it? All of this, byte, short, int, long, float, double, boolean, all of these are keywords. All the primitive data types are all keywords. You cannot use them again. No. You cannot say string char. No, it's a keyword in Java. You cannot use that. So that's one of the rules that exist. You cannot use reserved keywords. There are a lot of them, but you don't have to worry. Even if as long as you're using an IDE like IntelliJ will warn you and tell you, oh no, you cannot use this because it's a keyword, just like you're seeing here. Or when you try to run it, it's gonna give you an error. It's sometimes it's even not really clear what the error is, but it's gonna give you an error anyway and let you know that you can't use that. So unless you change it, right? So all right, what else is there? So these are the rules. It's a must. You must adhere to these rules. So we'll go to the next one. This will be our first assignment. But I think I would rather give you guys this assignment to take home. So basically, let me explain what this assignment will be. This assignment is actually a spec for a car called the Honda Civic. So I want you to imagine yourself as the person who is designing a program that will store all of this information. So I want you, when you do this assignment, what you're going to do is you're going to write a program that prints out all of this information. But each of this information, I want you to store them in a variable. Now look at this. These are the information, huh? Not this side. This is not the information. This is the description of the information on the left-hand side. But on the right-hand side is actually the information. So what I want you guys to do for this assignment, which you guys have to do now, you're going to take it home, is I want you to create a variable for each of this row, give it the right data type, and store the information that you see here. And when you've done all of that, I want you to print it out on the screen. So that means when I run your program should print out all of this information on the screen. You get it? I'll leave it to you to be creative on how to take care of this one. So you see like this curve weight is split into three. So use your creativity to see how are you going to save this? How are you going to store this in a variable? I'll leave that for you guys to use your creative imagination. I also see that some of the values, some are like this one is 2700 mm. I'm also going to leave it to you guys to use your creative imaginations, using what I've taught you guys to decide what data type am I going to use this. Am I going to split it in two? Am I going to put it together? Because half of it is a number and half of it is a text. How am I going to do that? So I'll leave it to you guys to decide, to be creative. What I really want to test here is I want to see if you guys know how to create variables. I want to also see if you guys can figure out what data types you're going to use for those variables. And secondly, thirdly, I'm curious to see how you are going to, what choices you're going to make when picking out the data types you want to use. So I will send this to the group. So for example, when this is an example of what the output should be, but I of course you have to print all of them. But when I run the program, for example, the wheelbase, you see, wheelbase, which is this, should print out 277 mm, which is what you see here on the right hand. And then the next one is track font /rare, which is this one, track font /rare. It's going to print out this information you see here. Yeah. And of course the rest of them. So that's what should happen when you run the program. So we're going to do this later. I'm going to send this as an assignment for you guys, because you guys have to get your fingers wet with variables. Variables are the ABC of Java and a lot of other programming languages. But now we're talking about Java. So I want you guys to learn it, to be very flexible with it, to know how it works, to soak yourself into it. Because once you understand the variables and how they work, understand the scope. Remember, we did scopes. You cannot have two names in the same scope. You understand all of that. Then you'll actually get yourself ready to start making sentences. So I'm just playing around with that, comparing it to natural language. So that's that. We're going to come back to this. I'm going to post this on the chat for you guys to do. So I want to hurry up. We have less than 30 minutes or a little over 30 minutes on the push down to more interesting stuff. So before we get into the more interesting stuff, I want to show you guys this part, which is called comparison operators. They're very important. Use comparative operator for decision making. For those of us or those of you that have done some kind of math, this would be very easy for you to understand. Just some things were a little bit different. So what are comparison operators? In Java, you're always making decisions. For example, I say, create a registration form that only allows people that are over 18. You guys have seen that a lot. There are some games you try to sign up to. You must be over 18. If you're not over 18, it's going to tell you no. How do you tell the program that you use comparison operators? Comparison operators takes one value and compares with the other value and then returns a true or false. For example, you see here we have this first comparison operator, which in Java you write this way with double equal signs. Whenever you want to compare if two values are the same, you use the double equal sign. This is what is referred to as equal operator in Java. I know in English or in basic math, let me pull out a notepad. In basic math, this is how you know it to be. You say 2 is equal to 2. This is how we know equality in math. In Java, no, that is not how we know equality. In Java, let me make this bigger. In Java, when you use only one equal sign, you are assigning something. This is what you call an assignment operator, and we've already played around with that. Let me show you. You see, we used only one equal here, so we are actually saying take Darlington and put it into char, into this variable name. Sorry. So this is an assignment operator. It's not an equality operator in Java. Please note the difference. Whenever you use one equal sign, you are taking something on the right and you're putting it into a variable on the left. But whenever you want to check if something is equal, so I want you to remove your head from the normal math equality, which we are used to. That's not how it works in Java. In Java, we use double equal sign. So that's what we see here. So in this case, we want to test if 2 is equal to 2. So this will return a true or false value back to the screen or back to whatever you want to do. And in this case, it will return false because 2 is not equal to 3. So let's see what that looks like. So we're going to run that real quick. So I'm going to get rid of this. Here, I'm just going to say 2 is equal to, or this is actually me saying is 2 equal to 2. So if I run this program now, it's going to return a true, see? So remember, I said comparison operators return a true or false value. And what data type is a true or false? Who can tell me? Let's try what data type? Sumba, what data type returns true or false? Can you remember?
Yeah.
What data type?
Boolean.
Boolean, exactly. So I can take this stuff here now and put it in a variable. How would I do that? I'll just come here, I'll say Boolean, and I'll give it a name, say my test, and then I can do this. And it accepts it because it knows that the result of this is going to be a true or false. Now let's run that. I'm going to take this now and put it in here. Run it. You see it returns true. But if I put 3 here, this will be false because 2, we know in arithmetic, is not equal to 3. So the comparison now is doing is 2 equal to 3? The answer is no. And how it says no in this declaration is going to return a false. So if we run that out, we'll see it returns a false. So comparison operators return a true or a false. I want you guys to remember that because we're going to use this a lot for decision making. The same goes for this. This is how you check if something is not equal to something. So the question here is 3 not equal to 2? What's the answer? Yes, 3 is not equal to 2. So it will return true. So whenever you think of yes and no, in Java, yes and no is the same as true or false. So yes means true, no means false. So if you can say it in English, and just say it in English, is 3 not equal to 2? Yes, 3 is not equal to 2. So you see the answer is yes, 3 is not equal to 2. So once you're having yes in your head, that's true. What about this? Is 2 not equal to 2? No. 2 is equal to 2. So you cannot say 2 is not equal to 2. So when no is coming in your head, then that's false. Now we are familiar with this one. So first of all, this not equal to, this is how you write it. Remember, very important. Then we have the less than sign, which is what we are used to in math. It also returns a true or false. Is 2 less than 3? Yes, 2 is less than 3. And remember, yes is synonymous to true. Then you have less than or not equal to, you have greater than, and you have greater than or equal to. All comparison operators return a true or false value, which is a Boolean. Right? Is there any questions here? Raise up your hand if you have a question. Alright, so we're still going to see how to use this. Of course, we've seen a little bit of how to use it, but we're going to see more why this is like when we are getting into making simple sentences. This is what you need to start learning to like say small sentences, like if you compare that to like natural language that you speak, right? So keep this in mind, comparison operators. The next one is logical operators. So these are also pretty much something we use in our English languages, right? So whenever you're thinking, we always think in logic somehow in our daily life. So my wife always sends me to the Jumbo, to the store next door, especially when she doesn't feel like going anywhere, and she tells me, Johnson, can you buy the small tomatoes or buy cucumber? So that message means it's either I buy small tomatoes or I buy cucumber. So I'm going to be coming with one thing, right? I'm going to be coming back with one thing. Is it I'm going to be coming back with small tomatoes or cucumber? So that's the or operator. That's what you see here. How do you say that in Java? You use the double sign. So you could say in Java, accept someone whose age is less than 12, or above 65. See the or there. So maybe someone wants to sign up to your game. The person has to be less than 12 or above 65. That means the whole people in the middle are not accepted. So it's the same way my wife says, go and buy tomatoes or cucumber. I cannot be coming back with an orange because it's not in the or operator. I have to come back with either this one or that one. That's how or works. What about and? We also use and in our daily life for logical decision. So you say, buy small tomatoes and cucumber. If I say that, then two things must happen. I have to come with both of them. If you put it in logic in programming, two things must be true. So how can we say that? We can say in programming, maybe you have a game. People that are registering must be above 18 and must be female. So you cannot, the two must be true. The program will not allow someone that is above 18 and a male. No. The two criteria must be true because you said the person has to be above 18 and must be a female. So these are the operators. And how do you do that in Java? You do that using the double ampersand. And then we have not. The not is a negation sign. The not is like saying, go and buy, my wife saying, go and buy orange, not tangerine. Orange. Or my wife says, go and buy something in the store, not tangerine. So I can buy anything I want, but not tangerine. So when you use that, you're negating whatever you put in front of it. So negation means you should not do that or take that into account. And we're going to look at examples of that, which are the lines you see below, right? So here we already see that we are already familiar with this part. This is a variable called an test. This is a data type. It's a boolean. So that means what this calculation is going to do is going to return a true or false. Now check this. The first line, the first two blocks is what? Remember, we did that here. Is a comparison stuff. We're using comparison operator. So the first two is saying 1, or we can turn it to a question, is 1 equal to 2? Can someone tell me what's going to be returned here? Let's give it a try. So Obi, are you back? Can you hear us? Okay, Obi's out of the picture. So let's go with if I help us out. What would this first part give us? Remember, it's a comparison operator, and remember what comparison operator returns? It returns a true or a false. So what would this first part return? False, right? And then good. But now look at what we're having in this ampersand. So remember, this ampersand is saying that it's an and. And means the two things have to be the same. So if this one is returning false and this side is returning false, what would be assigned to and text? Can someone tell me? That will be true. Yeah. Because remember, our and is saying both things have to be correct. My wife says, go and buy tomatoes and cucumber. The two things have to come back because it's an and. So the two sides when you use this logic has to be the same. So this is what you call a logical operator. Both sides, when you use and, have to be equal. Now let's go to the next one. Let's also just sample that real quick in code and see that is correct. So we're going to do that real quick here. I'm going to change this to and test. We'll run that real quick. System out. ln. Sorry, let's look at what is saying here. Remove cannot resolve method print ln bool remove. Okay, there is an error here. Alright, sorry. It's because my data type is supposed to be Boolean, sorry.
Right.
So there you go. And when we run this now, it's gonna say, oh, it's shooting out false. Let's see, why is that happening? So this is, I'm doing the right thing, right? So let's test this out. Let's test the first part out. Okay, so the first part is indeed printing out false. Now let's test the second part out. 2 is equal to 3. It's indeed printing out also false. And okay, sorry. I think it was my mistake. So I explained it the wrong way. When you use the and ampersand, which is very beautiful that we test this out. When you choose the and ampersand, both sides must be true. That's the mistake I made. Both sides must be true in Boolean, in the same concept. So since both sides are false, it's going to print out false. And that brings us to the idea of what we call the truth table. So I'm going to bring that into the picture. It's also something very popular with programming. So in your spare time, just go and type truth table. Truth table. So if you do truth table, go to images, you will see the same concept we just talked about. So which is let's pick a different easy one. So this is basically no. Let's use something else. Let's use the and. So this is the and truth table. Let me zoom in. So this right here is the and. Oh, let me get the picture out. Yes. I'm gonna zoom out. You guys might, especially for those in school, you would be familiar with this, or they will show you guys this very soon. It's called the truth table. It's it explains what just happened right now. So you see, we had false on this side, we had false on this side, and it printed out false. So the truth table explains that. So we are talking about the and, right? Remember, we are talking about this and ampersand sign. So this is the and truth table. And the and truth table says when the 0 means false, 1 means true. The and truth table says when both sides are false, the answer will be false. When both sides are true, the answer will be true. If one side or the left side is true, but the right side is false, it's also false. If the right side is false and the left side is true, it's also false. This is how the truth table works, and that's how your programming also works. So when you're using the AND operator, if both sides or one of the sides are false or is false, it will always return a false. So both sides must be true, and that's why we had that problem there. But now we're going to test the OR. So you see the OR truth table is a little bit different. The OR truth table only returns false when both sides are false. But at least if one side is true, it will return true. Let's test that out. So we're going to use the same code we used before to test it out. So I'm going to change this to an OR, which is double line, and then change this one to 2. So let's do a round again. Constance, can you tell us what this first block is going to return? A true or false? It's going to be false. Chidoso, can you tell us what this part is going to return? True. Okay. Now, based on our truth table I just showed you, so we had the first one was false, right? Which is this. and the right one was true. So A was A means right, B means left. Sorry, A means left, B means right. So remember, our left side was false and our right side was true, which is what we see here. Left side was false, right side was true. So Sumbo, can you tell us what we expect to get? So this, we are using the truth table. So this is the situation that we have. So what would be the answer? True. So you see, the truth table even tells us that. So if we run this now, we're going to see that we're going to get true. Because in the truth table, at least one of the sides must be true. But also, not only the truth table, think about it logically. You understand? Think about it logically. It's the same. Buy rice or beans. So whether you see rice only but did not see beans, you're still going to come back home with something. Whether you see beans but you didn't see rice, you're still going to come back with something. Whether you see rice and beans, both of them are true, you're still going to come back with something. The only time you will not come back with something which is false is when you didn't see both of them. You didn't see rice and you didn't see beans. So think about it logically. It all plays out in the real world. At least that's how I like to do it. When I think about it logically, it makes more sense to me. Like, oh, I can actually take this truth table and put it into real life, and it makes a lot of sense. So that is where all of this come into place. So we just played around with this, the OR, and we have the not equal table. We also have a truth table for that. That's what it's called, the XOR. The XOR is true when let's see if we have a good example here. Okay, so let me write a code that will show us that. So I think I can use something like this, true, and put the negation sign there. So what? So who can guess what's going to be printed out? So remember, the apostrophe sign is a not, that is a negation, right? So I put the value true and I put the not sign in front of it. So what Boolean value will be stored in this AND test? So let's try Chinoso. False, okay. Sumbo.
False.
Okay. Alright, now let's just run it and see. Exactly. It's false. Because it will give the negation, the opposite of what you have. Let's see if I also have another comparison. So I can also do something like this. 3. So, Obi, can you hear me now? I don't know if you're online. You're mute. Okay, so what do you think would be the value of AND test? So I have the negation sign. I said 3 not equal to 4. What Boolean value will be saved in AND test now? Okay, let's give it a shot and see. And that is true. So this is basically how we use the negation sign, and we're going to play around with that a lot as we keep going. So I think it's pretty logical if you think about it with our real world, the way we mess around in the real world. These things make sense. These are things we use in our day-to-day life. We use AND, we use OR, we use NOT. So we are trying to bring our real world experience into programming, because programming is basically telling the computer what you want it to do. And when you're doing that, you are most of the time creating decision trees, creating decisions that the program has to choose from when a certain situation or event happens, right? So let's move on. So I want to get us to an even more exciting part. And this is we're coming into the topic of control flow. Now you use control flow to make decisions. So, like I said, my wife sends me to the store and says, if there is pepper, if you go to the store and you find pepper, or what do you call it, Madam Jeanette pepper, if you find it, then buy plantain. If you don't find it, then buy banana. That's a decision statement. So in programming, how do you do that? We do that using what we call control flow. And one of them is the if statement. So we have the if statement, we have the if else statement, and we have the switch statement. What we're going to be talking about now is the if statement. How does that look? How do you tell the computer to use this control flow to decide? So we're going to look at first the syntax for that. How do you do that? This is how it looks like. You start with an if, you have a bracket, and then you put your condition in there. And the condition within this if will always return, or should always return, a true or a false. Because if it is true, it will go and read whatever you put into the block, and if it is false, it will not go into the block, it will go to the next line. And let's even go further to see how that looks. So this is basically an example. So we have here an example of a variable called user age. So remember I told you, people write games sometimes and they want people above a certain type of age to watch it. So it'll be like, okay, if the variable, the age or the number inside this variable is above 12, then print you are a teenager. So this is how you do it. Now remember, this statement you wrote here would always return what? A true or a false. You cannot write this. No, this will not work. This does not return true or false. This is an assignment operator. Remember I told you 1 equal to will take this 12 and assign it into user age. You are assigning. So this will not return true or false, and it will give you an error. So whatever you're going to put in the if statement should be a statement that returns a true or false. You can do something like this. See, this is an equality sign. You're saying is if the user age is equal to 12, that will return a true or false. So this is accepted. So I just want you guys to remember, in the if, first of all, the syntax is important. If, you see it also has a body, so it has its own scope. And in the if, you have to have a statement that returns a true or false. What about an else? What if you want to say if something is not true, then do the other? We do that with the else operator. So you have the if, we say if the fruit is equal to mango, then print delicious. But if this returns a false, then jump this and go to the else, then return ew. You understand? So let's go into code now and play around with that, because I want us to round up real quick. So let's go back to our code and see how that looks. So we're going to start with the things we already know about. We're going to have a name. We're going to have a variable, right? So we're going to do the first one string. The first one string, we're going to say the name of the person is let me say Darlington, and his age. Age integer. We're gonna say his age is, because you guys, you all know my age. I'm 20 years old. You know, I've been 20 since I can't ever remember. And now we're gonna have our what do you call it? Our flow, control flow. Because whatever this program want to write, we want this program to print a certain thing if the user, in this case Darlington, is above, let's say if he's above 18, we're gonna say you're allowed to enter. Let's put it like that. So we'll do that by saying if the age, which is the variable, the person is above 18, if the age of this person is above 18, you say you're gonna print system, because we want to print something out on the screen, system.out.print print line. You're gonna say welcome, but I want to say welcome. Then I'll put a plus here because I want to put the name of the person. Welcome, Darlington. Then I'll also add a quotation, open bracket. I'll say you may enter. Then I'm going to put an else here. So if this person is not above 18, then I want you to print system.out.println you are not allowed to enter. So let's run this and see what happens. So we run it now and it says welcome Darlington, you may enter. So this is quickly merged around because we need to put space here, do it again, and it says welcome Darlington, you may enter. But what if I change this to 17? Let's see, it says you are not allowed. So you see, this is where the decision happens, the condition statements happens. Do you understand? Now I want someone to explain this to me. What if I put 18? So you guys pay attention, please. Pay attention because you guys are going to solve this problem. So I put 18 and I run this. Oh my God, it says you are not allowed to enter. Can someone explain to me why? Like seriously, why? I'm 18 and I don't know, it's saying no. What's happening here? So let's try with Chinonso. Exactly. And that's because it's giving me this statement because this is exactly what I told you to do. I said only print this when the person is greater than. So 18 is not greater than 18. 18 is 18. So, but if I want to accept people that are also 18 in front of this stuff, which is something we are also familiar with in math, just put an equal to. So now I'm saying, oh, accept people that are greater or equal to 18. So we're going to print that out now. We're going to run that and we see we get welcome dogs and you may enter because I fulfill the criteria for this. Let's see what we have next because I want us to go into practicing now. Exactly. Time for us to play around with code. So what do I want you guys to do? So we have 2 assignments for you guys, right? So the first assignment would be, remember you guys, remember the last stuff we did? We took some inputs from a user, right? So what I want you guys to do is write a program. I'm still going to send this into the chat, right? I want you to write a program that asks the user for his first name, his second name, and then the age. And when the user puts in that age, it then checks if the user is above 18, and if the user is above 18, it should print welcome, name of the user, you may enter, and if not, it should say you're not allowed. Let me see how much time we have. Okay, we cannot do that within the time frame we have. So is my explanation clear? I'm going to paste also this code snippet into the chat so that you guys get familiar with them. You can use it to do the assignments or play around with it. Let me put it in the chat. And then you guys can start kicking it. So this is tied to the former stuff we did. So remember last time we accepted information from the user and we printed out something. In this case, I want you to accept the name, just 2 things. Accept the name of the person. So ask the person, what is your name? The person enters his name, or you ask it however you feel like, be creative with it. But it should accept the person's name and it should accept the person's age. It should ask the person, what is your age? And then it should print out, you may enter, or you may not enter, depending on if the person is above 18 or not. Is that clear? Chinonso is raising up her hand. Chinonso? Okay. Well, it's also pretty easy. I can just run it right here. So if the person is 17, so you see if this statement is ran, what would be the result of this statement? It will be false. So remember, we said that this statement, whenever it returns a true, it runs what is in this scope, in the if scope. If it is false, it will run what is in the else scope. So we run it now. So, sorry. I was wrong. I was supposed to change this. 17. So now it will return false. Sorry, I was supposed to change this. So it will return false because age is not greater or equal to 18. So we'll run it now. You see, the else part will get run because this statement will return a false as its response. Remember, this if block should always return what? A Boolean data type, right? That's what I told you guys. So that also means if you think outside the box a bit, you can actually take all of this and save it in a variable. I'll just take this now and say, okay, since that if always returns a Boolean, so I'll just say Boolean. I'll say, just give it name results. I can put it here. And then take this result and put it here. It will still do the same thing. See, you're not allowed. But if I make this now 18, so you see, if I make this 18, what happens is in this Boolean result, it checks if this age is greater than or equal to 18. It will take the result and put it here, and then I use it in my if. I run this now. It says, welcome down, so you may enter. So it doesn't matter if you bring it out here or you put it here. The point is, whatever you put in your if always should return a Boolean, a true or a false. Because based on that Boolean, that's when it decides if it's going to run this block of code or it's going to go to the else block of code. But what if you don't even use the else? What if you just take the whole else away? This is also allowed in Java. You don't always have to declare an else. You can also have an if. But what happens is, if the statement is false, it just will not do anything because you did not tell it to do anything. So now, let's give an example. So instead of 18, now we're going to make this 17. If I run this now, check. Nothing happened because it came into this block and this block was false and it just continued running and it didn't see any more instruction and it was like, okay, I'm done. But if I make this now 19, if I run it, it will come in here then and then print welcome down again. You may enter. So the point is, you can have an if statement without an else. That's okay. Yes. But that I will take in the next lesson. So I want us to start with this first. So first we'll start with this and we'll go into that later. Do we have any questions regarding the if statements and all of this? So if you have the opportunity, try to be creative with the assignments. I'm going to send the assignments into the group, but if you already get it, you can already get busy with it. So we have two assignments. We have one which is we have two assignments this week. One is using the if-else statements in deciding who may enter and who may not, and the other one is playing around with variables. I'm gonna send this to you guys. That's this one, where I want you guys to store all of this information into a variable and use the appropriate data type. This is very important, very crucial. Don't be afraid to make mistakes. Run your code If you get errors, look at the errors, figure out what it's about. If you get stuck, you can make a screenshot, post it on the chat so that you guys can help each other. I really want you guys to interact with each other and help each other out, because the best way to learn is to help someone else or to teach someone else. Or I could also answer the questions for you guys. Any questions before we round up? Are there any questions?
No.
No. Good. In the meantime, if any of you have any question, or you come across any other thing or code problem, just send it to me directly. I will do my best to respond to you guys. Thank you very much. I know I was supposed to stop an hour early, but I'm very happy that most of you were able to stay longer. The reason I pushed for it is, oh, actually, did we just spend 2 hours? I think we spent over 2 hours. Yeah, I think over 2 hours. But the reason for that is I want to get you guys to this if statement so that you guys can start doing stuff that are interesting, because when we get into the decision making part, things start getting fun. You start playing around with stuff. But everything we discussed today is the building block of Java. It's also probably going to be the building block of any programming language you're going to learn out there. But in Java, these are the rules. This is how you have to do it. These are the things, the concepts you have to understand. Use the words that we are saying. Use the word keyword. Use the word variable. Use the word data type. Get used to those words, because those are the words when you're communicating with other programmers. When you're in an interview, those are the words people will use. Like, okay, what data type should I use for this? If you don't know what a data type is, you're going to get confused, like, oh, what is data type? So use those words a lot, get familiar with it, and that's you learning to speak a new language that you can use for your programming. So thank you guys. I will send in the assignments into the group. You have a good day. Except, all right. Have a good one.
Thank you.
Bye.
Nice, everyone.
All right.